Hallo. Eine Kollegin von mir hat aus den USA.
A colleague of mine in the US ordered 20 small decorative branches on the internet for last Christmas. They reached their home, way too big of boxes, just a lot of packaging material. So basically air in plastic bags, right? But what was even worse was that every branch had its own carton and box. Just imagine you come home and you see that in front of your door. Well, it may be an extreme example, but we all know it. We all ordered something on the internet: cosmetics, shoes, clothes, electronics. And I believe that everyone is a Conrad.de customer here in Rome, presumably. So what you order comes in a carton of cardboard, and you very often think the box is too big. That leads to the fact that your product basically gets damaged, and I'm sure you have experienced that as well. And to prevent that, the excess space is often packed with air bubble foil, etc. And this leads to the fact that basically you have to get rid of the cardboard and also a lot of plastic. And whether the plastic is then recycled at all is questionable. Why is that? Well, I mean, we send space probes to Mars, but we can't send products in boxes of the right size? Well, the reason for this is that the mail order companies buy prefabricated boxes, often in large quantities, of course, in order to save costs. But there are two possibilities. Either you buy many different box sizes that fit well. Well, of course, they have to be bought, paid, stored, and managed, and that costs money as well. Or you have a few different sizes which then never fit properly, and they have to be filled up with air cushions or filling material. We have calculated that on average, 40% of all volume shipped is air. That means if you use correct box sizes, so in the smallest possible size, you can save 40% of the volume, meaning 40% less ships and less lorries and trucks. And that is basically the main reason and the main driver for Packsize, to buy the smallest, to produce the smallest possible box. So that means whenever you buy something on the internet, and then the box is basically produced where they also are sent out. And that looks like that. Would be nice, wouldn't it? Well, it exists already, and in real life it looks like this. Here you see the same orders that were ordered on the left-hand side, traditionally in fixed box sizes, and on the right-hand side in optimized packaging sizes, and the result speaks for itself. On an industrial scale, everything is of course fully automated and integrated into the superior SCADA systems and full data analysis, etc. So what Packsize does is to set up a machine in the delivery department and provide corrugated cardboard, where then the machine produces on-demand individually sized cartons. Every 6 seconds, one carton means 600 cartons per hour and machine. Large e-commerce customers operate many machine groups at the same time and can produce thousands of cartons every hour. Here we can see the standard carton design that you all know, and it is optimized to use as less cardboard, corrugated cardboard, for the best volume possible. To make such a box, the glue flap and the side flaps are cut out, and the box is pre-folded along the crease lines, and then all the cartons folds are positioned differently and they have a specific length, and then it is glued, etc., right way. And to produce things like that, we have challenges, because you see that all folding lines and all cut lines are positioned differently and they have dynamic lengths, and that happens every 6 seconds. Here you can see a bird's eye view. So from the left-hand side, it is fed and is worked on from different modules. And in order to achieve the high machine capacity, several cartons are being produced in the machine at the same time, and the changeover of the format happens smoothly. So seen from the side, the individual machine modules can be clearly seen. Corrugated cardboard is inserted from one side, processed, and folded into a box and glued. So the work is done by different modules: cutting, folding, and embossing the corrugated board. The modules that we use we have two different categories. The more complex ones, we call them stations. They have many axes. They are quite complex with regards to setup, etc. And we also have simple modules, mostly with one function and one axis. And if you look at the tools more closely, they all have the same basic function. So we have a base module that we assign different characteristics to. So for ones, it can be cutting, folding, embossing. So with these functions and these properties, or let's say these properties, can be easily translated into configurations that can be assigned to each base module. And then therefore we can also configure it in CODESYS for every module that we have. Why am I telling you this? Well, we have this machine that produces the cartons, the boxes very efficiently with the modules we have. So why should we modularize it? Well, not every e-commerce company wants to have this design. They want to have another design, also a standardized design, optimized for specific package sizes. Here we have the advantage that there is no gluing bit in the downside, so that on the underside, so then it stands quite stable. So with the help of our modules, we can produce this design as well. So we have to configure the modules differently and probably duplicate them in order to be able to produce this design. So it's the configuration of the modules that define what thing we can do. If we go one step further, you end up with more exotic designs, and that's where we can no longer cope with the existing technology and modules. Here, completely new methods and tools are needed to be able to produce the design. Let's take a closer look now. Here we have our tools and stations. We can replace the tools with a basic module, and of course beyond that we have just more other functions in our machine, because this is not enough, right? So Therefore, we have implemented other modules that are underlying then that ensure the basic function. So the OPC-UA module is one example that is added for every machine in order to be able to communicate with the outer world. We have a drive module that is added into every module that has a servo axis, and every servo axis has its own drive module. And in this drive module, all soft motion functions are implemented for this axles. And the great thing is, because of this abstraction, I have implemented the software just once, and I can reuse it. I also have a trigger module. A trigger module can be found in every machine part where we have a trigger sensor in order to detect the front part of the corrugated cardboard. So if I have a sensor in one of the module is added, and this trigger module publishes the information to all other modules that are interested. If we create a machine, then we select these modules that we need for this machine, and then we combine them in a tree structure. And this is what we could see in Mr. Doll's presentation before. If we want to have another box design, I just built this tree in a different way. So what does it look like in programming practice? Now here the tools come in place that we heard about before, and that CODESYS added to its toolbox a few years ago, meaning the application composer. Once the individual machine modules are available in this library, in our module library, then we can just combine them into a tree structure and create a machine configuration. And then the application composer, just at the push of a button, generates the finished machine code, just by integrating and combining logic, visualization, hardware, I/O mapping, alarm manager with each other. So to one ready-to-use code for the machine. This all sounds playfully simple, right? But unfortunately, it is not. Because the application composer is a very powerful tool, and such tools need to be mastered. And there are many obstacles to overcome along the way. Just besides assembling the finished machine or the tree structure, the module declaration is the central part of the application composer. Each module naturally contains its own source code. In addition, there is the definition of the hardware, so all devices that are in a module, so the drives, the I/O modules. Then added to that, we have the implementation of visualization, parameter data, up to trends. Everything can be defined and implemented in one module. The use of and the work with the module then takes place via the interfaces we know from CODESYS, and that are known from the project-oriented work in CODESYS, basically. A big advantage of this work with the composer is that it forces the developers to have a clean and modular design. They are forced to work project-oriented, because otherwise the whole thing doesn't work, and thus it is ensured that the code stays clean to the highest degree. And as soon as everything is implemented, a next step comes in, which is the module declaration. For that, there is a separate configuration language, or rather configuration file in CODESYS, where you can lose both the overview and the courage. Because, well, you're laughing, but errors in the declaration lead to the module missing functions at the end, that the hardware is not generated correctly, or probably it's generated correctly, but in the wrong spot in the tree. The visualization doesn't appear, or probably in the wrong place. And even though a lot is explained and written in the CODESYS online help, the devil is in the detail and in every single line of the module declaration. On our way into the world of the application composer, we asked ourselves several times whether we've made the right decision. My recommendation for those who want to go this way and this path is, for once, use the available training from CODESYS. It's a very good investment. Because only after the training you know and understand what is written in the online help. Above all, however, I would like to suggest you that you look for someone who can offer you help, be it an experienced CODESYS development house like we have with the company SDT, or, of course, the official support of CODESYS. With this, the goal is achievable and undreamt of possibilities open up. Because once a library of modules exists, new machine variants with already proven technology can be brought to the market in a short period of time. The development department can focus on developing new tools, basic tools, new stations, new technologies, and also other basic functions that we don't think of today. And of course, the existing modules must of course be further developed and maintained. So that means our development department doesn't develop new machines anymore, just as we did it several years ago. Our development department develops new modules and new technologies in module size. And with those new modules, we can produce new machines. And with that, we can react very individually and flexible to customer requests. And within just a few months, new machine designs can be built up and be brought into serious production very quickly. And this is another important part, that modularity is not only in the software. We saw that hardware is also modularized, electric as well, electrical components, but also when it comes to the production. We have production stations where only modules are built and tested. So we have developed module tests, where every module that is built has its own test and verification process that is undergoing. And basically, we can just put those modules on stock, and if we want to build a machine with these modules, we can take those modules and build and create a machine using those modules. The next step, then, of course, is when the machine arrives at the premises and is commissioned at the premises of the customers. Our service technicians, even if we have new modules, new variants, they know most of the machine components from the machines they've taken care of in the past. Let me conclude with a vision of what the future can look like. The cloud, and of course CODESYS and the CODESYS runtime are now running in the cloud as virtual PLC, of course, and also with CODESYS Go as a cloud service. And of course there in the cloud, there is our module library, where our developers save their modules. When we now want to start a new machine, then a service in the cloud loads the machine configuration from a database, takes the current versions of all modules from our library, and then generates an instance of the application composer, or starts an instance of the application composer that then generates the machine code, loads it into the machine, and then commissions it. And as I already said, our developers develop new modules, new concepts, and maintains the existing modules. Thanks to CODESYS and thanks to the application composer, we already have possibilities today that seemed unattainable just a few years ago. That seemed unattainable, we didn't want to believe in those, and many other things. And with this technology and infrastructure, we will be in a position in the future to constantly commission new machines and new machine variants, and also to bring completely new technologies to the market. And this allows us not only to react quickly to changes in the market, but also to supply new customer segments and industries eventually that seem out of reach today. Thank you very much for your attention, ladies and gentlemen.